May 2018 AS Applied Paper, question 5. A bias spinner can only land on one of the numbers 1, 2, 3 or 4. The random variable x represents the number that the spinner lands on after a single spin, and the probability that x equals r is equal to the probability that x is equal to r add 2 for when r is 1 or 2. Given that the probability that x is 2 is 0.35, find the complete probability distribution of x. So what I would do here is I would draw out a little table. And so we've got x, and we've got the probability that x is equal to x. And the values that we can take are 1, 2, 3, and 4. Now, what we know from the information given in the question is that the probability that x is 2 is 0.35, so I can put 0.35 in there. Now, what we also know is that the probability that x is equal to 2 must be the same as the probability that x is equal to 4, because we are told up here the probability that x is equal to r is the same as r add 2 for the numbers 1 and 2. So this has to be 0.35 as well. So what we've got is we've got 0.35 add 0.35, which gives us 0.7. 1 take away 0.7 gives us 0.3. And we know that the probability that x equaling 1 must be the same as the probability x equaling 3 for exactly the same reason as we've stated previously with 2 and 4. So 0.3 over 2 gives us 0.15 for each of these values. There. Part B. Ambrose spins the spinner 60 times. Find the probability that more than half of the spins land on the number 4. Give your answer correct to 3 significant figures. So what we can say is that this is a binomial distribution where we do 60 spins and the probability it lands on a 4, probability of success is 0.35. So if we're looking for the probability that more than half, so the probability that x is greater than 30, and that is going to be 1 minus the probability that x is less than or equal to 30. So again, putting this into our calculators, we get 1 minus 0.994, and so we get 0.00589, correct to 3 significant figures for part B. Part C, the random variable y is equal to 12 over x. Find the probability that y take away x is less than or equal to 4. Now, there are several different ways that you can go about doing this. I'm just going to show you the way that I thought around the problem and did it. So I replaced y with 12 over x, take away x less than or equal to 4. So what we've got is we've got 4 different values that x can be. So if we draw a table with our x value, and then we've got 12 over x take away x. So if x is 1, if x is 2, if x is 3, if x is 4. So if x is 1, we get 11 out of that. If x is 2, we get 4. If x is 3, we get 1. And if x is 4, we get minus 1 coming out. So looking at these possible values, I don't want to include 1, but I do want to include 2, I do want to include 3, and I do want to include 4 because they all give me answers that are less than or equal to 4. So the probabilities of each of these are going to be 0.35, 0.15, and 0.35, which gives me a probability of 0.85 that that event will occur.